Advanced polynomial long division means the following. A function and a null point are given. Find further null points. So this is not too complicated. It gets complicated when you have fractions or when you have some leftovers which you cannot divide completely. Then it gets a little bit more complicated. But in general, I would say polynomial long division is a quite nice type of exercises. I'm going to show you in the following how it works.
A function and a null point are given. Find further null points. How to deal with exercise like this? Actually, in this case we have to use the polynomial long division, and in this case actually we need a little bit deeper understanding of the division, except compared to if we just apply the polynomial long division. In this case we need to relate it to a function and to null points. So let's just calculate an example. So the function is the following. We have minus 4x to the power of 3 minus 5x to the power of 2 plus 7x plus 2, and we have also given a null point which is f of minus 2 is 0. And from this we can already say actually that if that we have power, the highest power is 3, so we can say that at most we have 3 null points, and one is already given. So at most we can calculate 2 more null points if there are 2 more. So the way we do this is actually because this is one polynomial, but this seems to be too big to just calculate it, or for example to apply the quadratic formula. So the thing is, we divide this big polynomial by another polynomial and make it a little bit smaller so that we can easily see or easily calculate the other null points. And the thing how to calculate I'll show in the following. So we just take well, let's maybe insert some more steps. So we have the polynomial I just introduced, and we want to say this polynomial should be 0, and we want to know where it is 0, except for this one. This we already know. And when we know that there is a null point at minus 2, then we can also say, or we can add an information in the polynomial, or we can, this is actually how it works, we say we divide by x plus 2. I mean, we can do it, right? Both sides are divided by x plus 2. And then it's 0. And then the thing is, we know already if x is minus 2, then we have a null point, right? So this is already known. And now we want to go one step further and find out where there are more null points. So we already know that this is a null point, and then we can calculate further. And the thing is, if we insert minus 2 here, then this is 0, right? We just said, okay, we already know that, so we can calculate further. And the thing is, we divide this by this, and why are we actually dividing it? Because we want to know something in the style of x plus 2 times something else. Because when we know that this is 0, I mean, this is if we have 2 terms and there's also an x in it, then we can say either this one is 0 or this one is 0, right? Then the entire expression is 0. So there are 2 possibilities. This one can be 0 and this one can be 0. So what actually the exercise gave us was at -2, the entire expression becomes 0. So in the end, if we take the entire polynomial apart, there has to be something like this, because this was given in the exercise. And what we do now is we take the entire polynomial and cut away this polynomial, this expression at the beginning, which was already given, so that we end up with just this part, because we know this has to be a part of the entire polynomial, and now we cut it away and we end up with this remaining part. And this is actually what we do when we divide by x plus 2. Right? So we just apply the polynomial long division now, and we cut away this information that we know it has to be included here, and we cut it away, and then we get out something smaller that is most probably easier to handle. And most probably in this case we will apply the quadratic formula, but that we are going to see later. First we need to cut away this expression from the big polynomial. And the way we do it, I already said, is we use the polynomial long division. So you just write it again, the big polynomial. And then we divide by x plus 2. So how do we get minus 4x to the power of 3? So we multiply x with minus 4x to the power of 2. Then we end up with minus 4x to the power of 3, because we multiplied with x, right? We also end up with, when we multiply this with 2, with minus 8x to the power of 2. We subtract this from our polynomial, and then this is 0, minus 5x to the power of 2, plus 8x to the power of 2 is 3x to the power of 2, right? Then we need another element, because it's always 2 in this case. We have 2 elements here that we divide by. Then we continue with plus 3x times x is 3x to the power of 2. 3x times 2 is 6 plus 6x. And we subtract this again. Then we know here's 0. 7 minus 6 is 1x. Then we take down this 2 plus 2, and then we know, okay, plus 1. And then we see actually 1 times x is x, and 1 times 2 is 2. We subtract this again, and we end up with 0. So no remaining part, it's a complete division in this case. And the thing we know now from this part, actually we can write, I mean that's just what we calculated, that minus 4x to the power of 2 plus 3x plus 1 times x plus 2 equals our big polynomial, minus 4x to the power of 3 minus 5x to the power of 2 minus 7x plus 2. Right? And what we did now is, actually this part we didn't know, we just had this polynomial, and what we said, we divide by this part, because we know the outcome, something like the outcome here, what we just calculated, times the information we already have, becomes 0. And I mean, this is just for what we had before. And then we just divided this polynomial by this polynomial, and we ended up with this one. And here we know, I mean, this is actually the already one step further than just our big polynomial as given in the exercise. So you can say we know already this, we already checked, or it was already given that when does this expression become 0, and the other thing is, when does this expression become 0? That we don't know, right? So the exercise we first received, as we received it, was when is this polynomial 0? And we couldn't really tell, because there was a power to the power of 3 in it, so quadratic formula we couldn't apply, so we had to cut it down a little bit. And the way we did it was with the second information given, And so this we can't directly check, but we can take it apart a little bit. So first part we already know, and this is the second part which is in it that we have to check. And we already see if we set this expression 0, then we can easily apply the quadratic formula. So that's what we are going to do. Minus 4x to the power of 2 plus 3x plus 1 equals 0. And then we apply the quadratic formula, which is the following, just to remind you. I just write it down. Minus b plus minus square root of b to the power of 2 minus 4ac divided by 2a. This is c. And then we just apply it. And so x1, 2 is minus b. So in this case, we can maybe take some color. This is what we want to calculate. So of course, minus 4 is a, plus 3 is b, plus 1 is c. So we take minus b, which is minus 3, plus minus the square root of b to the power of 2, which is 9, 3 times 3, minus 4ac, minus 4 times minus 4 is minus 16, times is positive 16 times 1, 16 plus 16, divided by 2a, 2a is minus 8. And then we already see, okay, 9 plus 16, this is very nice, 25. We can take the square root. It's minus 3 plus minus 5 divided by minus 8. Then we can further calculate x1, x2. So x1 is minus 3 plus 5 divided by minus 8, which is minus 3 plus 5 is 2. So we have minus 2 divided by 8. Then we can cancel 2 and 8. So we have 1, 4. We divide by 2. And we end up with minus 1/4. And the other one is minus 3 minus 5. Now with a minus, right? Minus divided by minus 8. Which is minus 8 divided by minus 8. Which is 1. So this is how we found the two more null points. We just took the big polynomial as it was given with a power of, with the highest polynomial 3 and degree of 3, and then we cut it down with the information which was given. So we knew when we have minus 2 given and we put it into this expression, this becomes 0. So actually it's always, this type of exercise always works with this kind of expression, x plus or minus something, so x, and then it's the negative expression, the negative value of x. Actually, it's always the negative of it. So negative of minus 2 would be 2, so it's always then in this case x plus 2. If it were 3, just f of 3 is 0, then it would be x of minus, then would be x minus 3, and we would divide the polynomial by x minus 3, but everything else, the procedure would be exactly the same. So this just to memorize you. So we cut down, we took apart the big polynomial, we divided it by the information which was given already in the exercise. That's this part, the polynomial long division. And then this is just to visualize it a little bit. And then we applied the quadratic formula, and then we found out about the two other null points. So it's actually, I would say it's not too difficult. Especially, I mean, this you have to know how to include this information that f of minus 2 is 0 to use it in the exercise, but otherwise it's just the regular polynomial long division, and this, of course, you should practice a little bit so that it's not a big problem. I mean, in this case, the numbers also fit quite good. Small thing which could happen is when we have some remaining part here, for example, 5, just to show you, maybe with black we have a 5. So if we didn't have 0 here but 5, then we would just add here at the end, we would add plus 5, because of course 5 can't be really divided by this, so we would not divide it by it, but just add it at the end. So we would add this term, 5 divided by x plus 2, because it can't be divided. We already saw it can perfectly divide it, so we don't have to add something like this. But this sometimes happens, and I know teachers and professors love that, to give you that problem in an exercise, in an exam, for example, or as homework. And then they want to see whether you can think, whether you have really understood it or not. But just memorize it. If you have some remaining part here, not 0, so maybe 5 or something else, also something with x, then you can't divide it by x plus 2, then you just add it at the end. Then everything is fine, and you just continue as usual. So this is how it works. Thanks for watching. Practice makes perfect. Further exercises with solutions you can find on my website, which is www.worksheets.com.